This is the video for Unit 10, Day 4. We're going to look at proving triangles similar today. Homework is packet page 34 and 35. We have 3 warm-up questions. So if you could pause the video, after you're done with it, hit play, and there'll be 3 things that come up for you to put in your answers to the warm-up questions. So go ahead and pause the video now. All right, the first one, 3, -7 is in the pre-image. We're dilated with a scale factor of 4. So A prime should be each of those multiplied by 4. So we should have 12, -28. B dilated from the origin with a scale factor of a half. So B prime should be -3, comma, either 2.5, or you could have said 2.5 is a fraction. So if you had -3, comma 5 halves, that is fine as well. So we don't know the coordinates of C in the third one, but we know the image should be 9, -15 after we multiplied by 3. So we know 3 times our x should give us 9, and 3 times our y should give us -15. So if we divide this by 3, we get our original x is 3. Divide this by 3, we get our original y is -5. So the original point C is just 3, -5. Moving over to the homework, we had points A and B. We're going to dilate scale factor of 3 from the point 1, comma 5. So from 1, 5, to get to A, we went down 2 and left 3. Well, we want to multiply those 3 by 3, or in other words, do that 3 times. So down 2, left 3, down 2, left 3 again, down 2, left 3, and that takes us to A prime. From our point to B, we go down 1, 2, 3, 4, and left 2. So do that 3 total times, so twice more. 1, 2, 3, 4, 1, 2. 1, 2, 3, 4, 1, 2. So that gives us our B prime. Notice our center of dilation was not on our original line, so our image was a line that was parallel to the original. Scale factor of 7, so just multiply by 7. So A prime is 21, comma, -14. The y-intercept is 3. We're dilating by 4 from the origin, so 3 times 4 just gives us 12 because it should be a parallel line. 0, 0 is not on that because if you sub in 0, you get 0 equals 3, which is not true. So that's why we know it's a parallel line and not the same line. -1 times 3 is -3. 5 times 3 is 15, so that's why our scale factor is 3 in number 4. If you sub in 2, 4 to our equation, that'll give us 4 equals 6 minus 2, or 4 equals 4. So that means our point is on the line, so therefore we should have the exact same line when we dilate it. So our center of dilation is not on the line, so it should create a parallel line. So that gives us choices 1 or 3. And if we're dilating by a scale factor of 5, the image should be 5 times the original. So 5 times the original JK should equal our image, so that's why we'd have choice 1. Seven was a pretty hard question. So RS is dilated by a scale factor of 4 with center at R. So first off, if we're dilating RS and the center is at R, that means our center of dilation is on the line. So therefore, we're going to have the same line, so it's going to be collinear. So if S needs to be 4 times as far away, so here's one jump, 2, 3, and 4. Well, notice they're comparing S prime to RS. Well, here's S to S prime, which has 3 parts, and this has 1 part, and those are all equal parts. So that's why it's 3 times RS is equal to SS prime. And that was a hard question. This goes back to our point slope form we talked about early in the year. Y minus y1 is equal to our slope times x minus x1. Well, 0, 0 is not on this line, because when you sub it in, it doesn't check out. So we would need a parallel line to our original one. Parallel line means same slope. So it's got to be either choices 2 or 4, because we need that same slope of 3. Well, notice in our original setup, we have a minus. So if we have plus 5 and minus 7, that's really the point negative 5, 7. Multiply them by 4, because the scale factor of 4, you get negative 20 and positive 28. Put those back into our point slope form, and that matches with choice 2. So we're going to be on page 29, looking at our notes for day 4. We're going to learn 3 different ways to show that 2 triangles are similar. The first way is a way we will see in algebraic type problems and also in proofs. The other 2 that we see will only be in algebraic problems. So our first one is the angle-angle similarity postulate. If you have 2 angles that are congruent to 2 corresponding angles in the other triangle, then we know the triangles are similar. And the reason for that is we know similar figures in general should have all sets of angles congruent. Well, if 2 of your angles are the same in the triangle, then the third one must be. So for example, if I had 30, let's say this was 50, that was 30, and that was 50. Well, those together add to 80, so both would have to have 100 for the other one to get to 180. So if you know 2 are the same, really the third is going to be the same. So this is called the angle-angle similarity postulate. That squiggly again means similar, and we can use it to show triangles are similar anytime there's 2 sets of angles congruent. A similarity statement, like a congruent statement, has to match up. So T had 1 mark, that would go with P in the other triangle. R had 2 marks, that would go with L, and then M for the third one. Our second way to prove triangles similar is side-side-side similarity theorem. When you're doing similar, S's do not mean congruence, they mean proportional. So notice here, this is the small, the medium, and the large. They would correspond to the small, medium, and large in the other one, because they might not be oriented the same way, so you would want to look out for that. So we're going to take our small over our small. So 6 over 3, that reduces to 2 over 1. Then take your medium over your medium. So we're going to do 8 over 4. That also reduces to 2 over 1. And then do our large and our large. So we'll do 10 over 5. That also reduces, if you divide by 5, to 2 over 1. Notice they all had the same ratio. So we would say these are similar by side-side-side similarity because all 3 sets of sides are proportional. Now, if we had to make our similarity statement, name the first one anything you want. So maybe we'll call it WYX is similar to triangle. W should match with R, and then T, and then S. If we go over to page 30, our third and final way to prove triangles similar, or to show that they are similar, is side-angle side similarity. Remember, anytime you have an S for similarity, that means the sides are proportional, not congruent. But A's do mean they're congruent. So here's 2 sets of angles marked congruent. So of these, this is the larger, that's the smaller of the sides we have labeled. So if we do our small over our small, 10 over 4 reduces to 5/2. If we do the large over the large, divide those by 3, and you also get 5/2. So on either side of our congruent angle, we have sets of proportional sides. So we could say these triangles are similar by side angle side similarity. And our similarity statement, we could say triangle ABC is similar to triangle. A would match with D, B would match with F, and then E. So you name your similarity statement much like we named our congruent statements. All right, moving down to the bottom, we want to know if these triangles are similar. So we don't have any side length, so the only option is angle-angle similarity postulate. We've got the 58, so that's one set of angles congruent. And if that one's a right angle, the other one is too. So are they similar? We would say yes. The similarity statement, we could say triangle AMX is similar to triangle. A was the 58, so that should match with B. M was the one we didn't have marked up, that should match with K, and then the X. And then our reason, we would say angle-angle similarity postulate. Note, this one is a postulate, the other two are called theorems. Postulates are kind of like rules of the game. They're accepted facts. Theorems are things that still have to be proven. So in B, we don't have three measurements of sides, so it can't possibly be side, side, side similarity theorem. We've got two sets though, and notice we've got a set of vertical angles there. Well, this is where it's helpful to notice small and large. So in the left triangle, this one's smaller, that one's larger. Here, this one's smaller, that one's larger. So when we do our proportions, we need to do small with small and large with large. So we'll take the 12 from the left-hand triangle. That should correspond to the 24 in the other one because they're both small, and that will reduce to 1/2. We'll take the 18 from the left-hand triangle. That matches with the other large one from the right-hand, 36. And 18 is half of 36, so you also get 1/2. So the sides on either side of the congruent angle are proportional. So we would say that yes, this is similar. We would say triangle ZVY is similar to triangle. This Z should match with that X. The V's would be the same, and then the W would match with the Y. Our reason, we would say side angle side similarity theorem. Going over to the next page to look at letter C. Well, we have three sets of sides here, so probably want to test out side, side, side similarity theorem. Well, notice we have two that are tied for the smallest and one for the largest. So the smallest ones we should compare. So I took the 6 from the bottom and the 8, and you get 3/4. Do the other 6 and the 8, and you get 3/4. And then we'll take the 9 to the 12, and you also get, when you divide those by 3, you get 3/4. Now I went the bottom to the top. You could have gone the top to the bottom as well. So you could have done 8 to 6, 8 to 6, and 12 to 9, and you just would have gotten 4/3 for all of them. Notice they all have the same ratio, so we would say our sides are proportional. So yes, they are similar. We can say triangle EGF is similar to triangle. Now, the big thing with this one is, because we've got isosceles, we need the E and the F to match up with the A and the B. So the A and the B's need to be on the outside, and then the C would be in the middle. So ACB we'd need. And our reason for why they're similar, we would say side, side, side similarity theorem. These ones are similar idea, no pun intended. Notice we have an angle here, but we also have all three sides. So we really have options. We could maybe try side, side, side similarity theorem, or we could do side, angle, side. I'm going to do side, angle, side because that's potentially less work. We already have one angle. So looking at those, let's do the small with the small. So that would be 9 to 12. Divide those by 3 and you get 3/4. And then do the 12 to the 16. If we divide those by 4, we get 3/4. Well, our sides on either side of the congruent angles were proportional. So we could say that triangle PXM is similar to triangle. P was our right angle, so that goes with W. X was in between the medium and the largest side, so that should match with A, and then L. And our reason that we just did is side, angle, side similarity theorem. Now, if you didn't recognize the angle there, you could have just done another set of sides, do the ratio, and done it with side, side, side similarity theorem, and that would have been fine as well. So 130 and 30 is 160, so that gives us 20 for this spot. 20 and 30 is 50, so that gives us 130 for that because we need to make sure that they add to 180. Well, notice we have two sets of sides, or two angles congruent, sorry. We actually have three, but we just need at least two. So these are going to be similar. Our reason, we would say angle, angle, similarity postulate. And that's the reason we're going to be using when we do two-column proofs for these later. And our similarity statement, maybe we'll go NMJ. Well, when we have the angle measures, this is a lot easier. N was the 20, so that matches with B. M was the 30, that matches with A. And J was the 130, so that matches with C. Moving on to page 32, we need to tell why the triangles are similar and then also find the missing side. Because once you know they're similar, then we can set up a proportion because we know the side should be proportional. So first off, these are similar. They have two sets of angles congruent by the angle-angle similarity postulate. Well, let's start with the x. The x is between the right angle and the no mark angle. That needs to be in between the right angle and no mark in the other one, which is 5. So then if we go back to the other triangle, we have 9, which is between the right angle and the single mark. Right angle and single mark is 6 in the other one. We'll cross multiply to get 6x equals 45. And if we divide by 6, you could either leave that as 15 halves if you divided them both by 3, or that's the same as 7.5. In this one, we've got our small triangle and we've got our big triangle. Notice they both share an angle, so that angle is congruent by reflexive. If we take a side from the small 12, that corresponds to a side from the big of 20. Those both can be divided by 4 and we get 3/5. We'll then take a side from your small 15 divided by the side from your big 25. And if you divide those both by 5, you also get 3/5. So we have a congruent angle between them, and on either side of that, we have sides that are proportional. So this would be side, angle, side similarity theorem. Well, let's start with the x. The x is in the big triangle. That matches with the 17. Now we have to pick something from the big triangle. We got to make sure it's the whole side. So let's maybe go with the 20. And that matches with 12 in the small triangle. If you cross multiply, we'll get 12x equals 340. We can divide both sides by 12. And when you divide that, it doesn't come out nice, so we want to make sure to leave it as a fraction so it's in exact form. So that's x is going to be 85 thirds. Moving down to C, we again have this picture where we've got the small triangle and we've got the big triangle. You want to be on the lookout for that in this unit, because when you have that, you're going to get an angle by reflexive like that. That's going to be really common. The other thing that we have is we've got corresponding angles congruent because of parallel lines. So this angle would be congruent to that angle, and you could have got the others congruent as well, but that's all we need is 2. So we'll have them similar by the angle-angle similarity postulate. Aside from the small triangle is 3, and that corresponds with 8 from the big triangle. Aside from the small triangle is 4, and be careful, in the big triangle, we need to add those together. So the big triangle would be x plus 4. When we cross multiply, we'll get 32. And that 3 will have to distribute to both parts of the x plus 4. So we'll get 32 equals 3x plus 12. Subtract the 12. That's 20 equals 3x. And when you divide by 3, decimal form, that doesn't come out nice. So we want to leave that as the exact value of 20 thirds. By come out nice, I mean it does not terminate. In D, we already have a right angle, and then we've got our vertical angles. So there's 2 sets of angles. So these are similar because of the angle-angle similarity postulate. So the x is between the vertical angle and the right angle. That matches with the 12. And that's equal to the 42 over the 14. So you can cross multiply this and do this in your calculator, but I just want to show you one technique that we'll use later in a later unit that can be helpful. On the side that just has numbers, like 42 over 14, you can always reduce that, and it might make life easier. 42 divided by 14 is actually 3. So you could actually rewrite this as 3 over 1 if you wanted. You don't have to do it this way. You could just cross multiply. But notice now you just get x equals 36 and you're done. If you had cross multiplied right from the start, you get 14x equals 504. And when you divide by 14, you're also going to get x equals 36. Okay, same answer. It just is a little bit smaller numbers if you reduce them. And the reason for showing you that is on the SAT, there's often proportions in the no calculator section. So you wouldn't want to have to multiply that out to get 504. If you can work with smaller numbers, if it's a no calculator section, that's always helpful. So our last page for this video, over on 33, we got 2 more questions. We want to tell why the triangles are similar and then find x again. Well, here's our really common picture in this unit. The small triangle sitting inside the big triangle. They're sharing this angle by reflexive property. Along with the right angle, we now have 2 angles, so we have angle-angle similarity postulate. Well, the x matches with the 110 in the small triangle. X was from the big triangle. In the big triangle, we would have 180. So 180 matches with the 90 in the small triangle. If we cross multiplied, we'll get 90x equals 19,800. And if we divide by 90, we'll get x is 220, and we have yards. Well, our last one, we've got the right angles. We got vertical angles here, so two sets of angles congruent. These are similar by angle-angle similarity postulate. The x will match with the 15, and the 120 will match with the 20. You could reduce that if you wanted, the 120 over 20, or just cross multiply right away. You get 20x equals 1800. And we divide by 20. One way to do this in your head is basically reduce it by a factor of 10. So you'll have 180 over 2, and 180 divided by 2 is just 90, and we've got feet. That's it for this video. Have a great rest of your day.